today's lecture is taking normal distributions and applying it to probability. So it's actually really similar to what we talked about in the last lecture. So it's going to be a little repetitive, but it's the idea that now we're taking what a normal distribution is and using it to calculate probabilities, just like we did with binomial distributions. Okay, so let's just write down a couple of things that would be important. So we can find the probability that a random variable, remember we call this random variable x, lies within a certain interval. Let's just review what this means with a sketch. Okay, so we talked about the normal distribution. Okay. So we said that this is the mean. And when we talk about probabilities, what we're really talking about is what is the probability that something falls into a certain area of this curve. Okay, so we might say, what is the probability that, essentially think of it like throwing a dart. What's the probability that we fall within this area? And the probability is 50%. If I were to throw a dart and I knew it was going to land in here, the probability it lands within this area is 50%, because 50% of the area under this curve is over here. Okay. Whereas if we're talking about standard deviations, we're using standard deviations. We said, if you remember in the last lecture, that if we're one standard deviation below to one standard deviation above, remember this represents standard deviation, the probability that we fall into this area is 68%. This is standard deviation, one standard deviation above to one standard deviation below. So in the first half of the curve, okay, that's a 50% probability, whereas in the center, from one standard deviation below to one standard deviation above, it's 68%, because 68% of this curve, 68% of this area is between one standard deviation below and one standard deviation above. And this is true for every single normal distribution. Okay, that's why we call it normal, because it's standard, it's the same. So it doesn't matter what these numbers are, the mean might change, the standard deviation might change, but if it's normally distributed, then under this curve, always 68% is going to be between one standard deviation below and one standard deviation above. Okay, so we're going to take some examples and we're going to work through them, and what we're going to use those z-scores again, because those z-scores tell us what percentage of the area falls beneath or before a certain standard deviation. Okay, so let's just take an example and work through it. So let's say that I'm going to keep these relatively short in terms of writing them. So we're going to say a national study this is saying that we have a national study. It is looking at how many hours per week a college student works if they have a job. So notice all of these, they're going to give you an average and they're going to give you a standard deviation. Okay, and then from here, we're going to ask the same questions that we asked with like probability distributions. If we were to take one more college student who has a job, what is the probability that they would work less than 4 hours a week? Given this information, what's the probability that the next college student works less than 4 hours a week? So we're saying that this is normally distributed, because if it's not, then this would not be the way to do this. Our question: what's the probability that the next college student works less than 4 hours per week? So remember what X is. So we're going to define this for this one. We don't have to define it for all of them. Okay. X is the number of hours per week. A college student with a job works. Our random variable. So our random variable is always revealed in the question, okay? But it's also revealed here because it's what we're measuring, okay? So what we're measuring is the number of hours a week that a student works. So that's what X is. And how are we going to do this? We're going to use the z-scores, because we're going to find, well, where does 4 fall on this curve? And then what's the area of the curve before 4? So here's our normal curve. We know that this here is 22. We know that the standard deviation is 9. So if we look here, one standard deviation below and one standard deviation above, this is one standard deviation. This is one standard deviation. So this is 13 and this is 31. Now we know that 68% falls between 13 and 31, but that's not what we're looking for here. What we're looking for is what's the probability that it's less than 4. So what we're going to do is we're going to find 4 on here. And we're going to say, well, what is this area under here? Okay. And how do we do this? We need a z-score, because we have to know our normal curve is based on the standard deviation. So we're going to find the z-score, because that's going to tell us the number of standard deviations away from the mean. It's going to tell us where we are on the normal curve. Okay. How do we find the z-score? We do our mean. We do our random variable, the random variable that we have, minus the mean over the standard deviation. So here our random variable is 4. Our mean is 22 and our standard deviation is 9. So if we plug that in, we get -2. So our z-score, and we'll put this up at the top, This is a repeat, right? Is the number of standard deviations away from the mean. It tells us where we are on the normal curve. So we're at -2. So what we're looking for, I'll put that in here too, just so that you can see it on the, when it's written here. If this is -2, then we're looking for this area over here, okay? Just like we're saying here. It's just that in this case, we're gonna label it with actual numbers, okay? So that, but even if we label it with actual numbers, we still have to figure out, well, how far are we from the mean? And then what we're going to do to find this area is we're going to use that z-score table. So the number in the z-score table tells us the area under the curve to the left of the z-score. Now here's the thing, because it's telling us the area under the curve to the left of the z-score, what it's also telling us is the probability that we are less than that z-score. So in other words, what we're saying here is the probability that x is less than 4, which is what we're looking for, is the same thing as the probability that z is less than -2. That's the same exact thing, because this is the z-score for x. So, and the probability that x is less than 4 is equal to this probability is only true in this particular data set, right? In another data set where the average is, let's say, 100 and the standard deviation is 6, this would not be true, okay? So it's based on the z-score. So for this data set, because the z-score for 4 might be different if the mean and the standard deviation is different. And if we go to our nice little z-score table, okay, what we're looking for is we're looking for -2. So we're below the mean. So we go to the negatives and we go to -2.0. So here's -2, it's 0.0. So it's 0.0228. So let's think about what this tells us. What this tells us is that there is a 2.28% chance that the next person is going to be working less than 4 hours, okay? Let's put that on the next page. outliers, things like that. This is what we're seeing is if there's less than 5% chance, then it's actually of rare occurrence. So this is less than 5%, so we would consider this a rare event. That's, if you have a college student, it's rare that they would, that it would be rare that they're working less than 4 hours per week. Okay. Okay, let's do some other examples. Let's say that we want to find the probability that X is less than 10. Okay. So same data. Find the probability that X is less than 10. I'm going to write this here. I'm not going to write this for every problem that we put here. Okay. What this means is the probability that someone works less than 10 hours per week. We're going to use the Z-score chart, but in order to use the Z-score chart, we have to find the Z-score. So we're using the same mean and standard deviation. So this time it's going to be 10 minus 22 over our standard deviation, which is 9. So if we go to calculate this, we get negative 1.33. Remember, round to the nearest hundredth, because that is our, that's what our Z-score chart is based on. Okay, so what we're saying is the probability that X is less than 10 is the same as the probability that Z is less than negative 1.33. So if you think about it, what we're doing is we're saying we're somewhere over here on our normal curve, okay? And we want to know, well, what's the probability? What's the area under the curve over here? Okay, again, think of it as throwing a dart. What's the probability that you land in that region right there? So all we have to do is go to our Z-score chart. And we go to negative 1.33. So we start at negative 1.3. And then we go over, and remember, this is negative 1.30. So then we have negative 1.31, negative 1.32, negative 1.33, and that's 0.0918. So what does that tell us? That tells us that there's approximately a 9.2% chance that the next person works less than 10 hours per week. One more. Let's find the probability that someone works less than 29 hours per week. So once again, we have to find the z-score. So we're going to do 29 minus 22 over 9. Okay, so what that's doing is it's telling us where on the normal curve we are. And notice this is telling us that we are above the mean. So round to the nearest hundredth, this is 0.78 when we round to the nearest hundredth. And what do? We say, okay, well, the probability that it's less than 29 hours is the same thing as the probability that your z-score is less than 0.78. These are equivalent. So we go to our z-score table. We go to the positives this time because we're above the mean. And this is saying that the area under the curve, when you're 0.78 standard deviations above the mean, is 0.7823. Okay. And notice what this means. This means there's a 78% chance that the next person works less than 29 hours. And notice that your probabilities get much higher the closer you are to the mean. Okay, as you get closer and closer to the mean, your probabilities are going to get higher here. Okay, and then as we go past the mean, they get even higher. So let's just take a look at that. If we look at the normal curve again, right? Once we get to the mean, it's 50%. As we move past it, there's more and more area that we're covering. So if we're all the way over here, now we have all of this area. So the percentages get higher and higher. And then finally, when you get all the way to the right, you get very, very close to 100. Okay? Okay, so let's take another situation. Let's take the probability that a student works more than 31 hours. Okay, so now this is a greater than. So I'm going to put this in here because I want to point out the difference. I want you to see it. Okay, the probability that somebody works more than 31 hours per week. Well, we still need to find the z-score, okay? So that doesn't change because we have to use that z-score table. So it's going to be 31 minus 22 over 9. And this tells us that we're exactly 1 standard deviation above the mean. Now let's just, again, here's a sketch of our normal curve. Here's our mean. Here's 1 standard deviation above. I'll put in this so that you can see it's 1 standard deviation. Here's what the z-score table is going to tell you. The z-score table is going to tell you this area. But that's not the area that you want. You want the area on the other side. So how do you get that? Well, you take the whole area, which is 1, and you subtract what you're being told. So here's what we're saying. We're saying that the probability of x greater than 31 is equal to 1 minus the probability of z less than 1. Okay. This is also one minus the probability of x less than 31. Okay. So what's the probability that z is less than 1? We have to go to our z-score chart. Well, here's 1. 1.0 is 0.8413. So we want 1 minus 0.8413. So how do we get 1 minus 0.8143? 0.8413. And our answer is 0.1587. So remember that when it's greater than, you have to subtract from 1, okay? Because you're only getting the area on the left, and when it's greater than, you actually want the area on the right. Okay, let's take a completely different example. Let's say the average speed of a vehicle on a highway is 67 miles per hour. And the standard deviation is 3.5 miles per hour. Okay, so let's find the probability. I'll put this, we're going to do a bunch. We'll do a couple, so I'll do an A. Let's find the probability that, remember, this is all randomly selected because it's random variables. So a randomly selected vehicle is violating the 70 mile per hour speed limit. So think about what this means. This means we need to find the probability that someone is going faster than 70 miles per hour. So we're looking at the probability that x is greater than 70. So again, automatically, we know we got to find that z-score. That's the only way to do it. So our z is equal to 70 minus the mean. The mean is 67 over 3.5. And this I already calculated, it's 0.86. So that means that the probability that x is greater than 70 is the same thing as the probability that z is greater than 0.86. But remember, our z-score, okay, on the z-score table, it doesn't give us the probability that z is greater than 0.86. It gives us the probability that z is less than 0.86. So we need to calculate that. We need to subtract that from 1. we're going to go to our z-score table. I'm getting to love this table. We go to 0.8 and we go over to 0.6. So a reminder, always look at the column and make sure that you're in the right column. So it's 0.8051. So we're saying it's 1 minus 0.8051. And we get 0.1949. So think about what this means again. This means that there's a 19.5% chance that a random vehicle, randomly selected vehicle, is over the speed limit. Okay, a 19.5% chance. Writing it out, I'm just going to write this out. Let's say that we want to know what is the probability that somebody is going between 25 and 70. Okay, so a lot of times there isn't a minimum speed formally on most highways, but there is a minimum speed that would be safe. Right? So if you're driving on a highway, you're not going to want to drive at 10 miles per hour. That could wind up being dangerous to you and other drivers. So let's see what percentage of cars are falling within an interval. So we did this already, right? We did it in the last lecture where we said, okay, if we want to know what percentage of cars, we're just making up some interval. If we want to know the area between this interval here, okay, well, here's what the z-score tells us. We could use the z-score table to give us this area here. We could also use the z-score table to tell us this area right here. So if we take the purple and we subtract the green, what are we left with? We're left with the area in the middle. Okay, so what is this equal to? This is the probability that x is less than 70 minus the probability that x is less than 25. Because that's what it's going to give us. It's going to give us whatever is left over. So we're taking the area for this further distance and subtracting it from the area before the smaller distance. And what are we left with? We're left with the area in the middle. So you can see if we subtract the purple and the green, if we take out that overlapping part, then we're left with the red here. Okay. So how do we find this? Well, we have to find the z-scores for each one. So we're going to find the z-score for 70, and then we're going to find the z-score for 25. So it's 70 minus 67 over 3.5, which we already know from the previous one that it's 0.86. And now we're going to find the z-score for 25, so 25 minus 67 over 3.5. And if we go to our calculator, we get, that doesn't make sense. I guess it does. Okay. So you can see, so this is, I'm glad that we did this problem, okay, that I made it 25. I didn't think about it that much, but this is a good problem to do because what you can see is that the z-score is at negative 12. Okay, well, let's go to our z-score chart. Our z-score only goes up to 3.4, right? And it only goes down to negative 3.4. Now, what this tells us is that nobody is going at 25 miles per hour. Nobody. Okay, so because it's too large, okay, it's telling you that this is not, that the range of people, it's not 25 miles per hour. You have no cars going at 25 miles per hour. They're all going faster than 25, okay? So if we do this, because I already have it up here, essentially what you're doing is 0.86 minus 0. Or 0.86. Let's do another one that isn't as crazy. I'll estimate it better. Let's do the probability of 58 to 70. That's not going to give us the 0, okay? There are going to be cars going at 58 miles per hour. Again, the fact that we got a z-score of negative 12 for 25 miles per hour tells us no car is going at 25 miles per hour. That would be an example of a speed that would not be safe on that highway. So again, what is this? This is the probability that somebody is going less than 70 minus the probability that somebody is going less than 58. So we need the z-score. So we already know the z-score for 70. We'll write it down again. Now let's find the z-score for 58. So 58 minus 67. Sorry. Now we get negative 2.57. So the probability of 58 less than x less than 70 is the same thing as the probability of z being less than 0.86 minus the probability that z is less than negative 2.57. The probability that x is less than 58 is the same as the probability that z is less than negative 2.57. So let's go to our z-score chart. So we're going to go to 0.86, 0.8051. So let's fill that in. And now we're going to go to negative 2.57. So here's negative 2.5, and we're going to go all the way over to 2.57, which is 0.0051. And what we get here is 0.80. This wasn't a hard calculation because we had a 5-1 and a 5-1. So this is just 0.80. So there's an 80% chance that a vehicle is going between 58 and 70 miles per hour. Okay, let's take another example. Let's say the average time a person spends in a supermarket on any given trip. Is 43 minutes with a standard deviation of 12 minutes. So we're going to do two things here, okay? We're going to find probabilities, but we're also going to say, okay, well then, based on the number of shoppers in a store, how many would you expect to fall within a certain category? Okay, so we're going to find two things. So I'm going to use A, B, and C. We'll do 3 examples. Let's find out the probability that a shopper spends more than 37 minutes. Okay, so again, we already know that we need to find the z-score. So now it's 37, it's our x, minus our mu, which is 43, that's our mean, over our standard deviation, which is 12. So notice I do the subtraction first and then I do the division. If you want to do it in one step, the 37 minus 43 has to go in parentheses. So we get negative 0.5. So the probability that x is greater than 37 is 1 minus the probability that z is less than negative 0.5. So remember, our z is always a less than because that's what the table tells us. So if we go to our z-score chart, and we go to negative 0.5, it's negative 0.50, so it's 0.3085. And if we go to our calculator and we subtract that, we get 0.6915. So let's add on to this question a little bit. Let's say if there are 200 people in the store, how many will fall into that category? So how many will shop for more than 37 minutes? All this does is it gives us a number to look at. It gives us something a little bit more exact. So this is saying that 69.15% of shoppers are there for more than 37 minutes. That is more than. Okay, I'm just abbreviating. So we just take 69.15% of 200. How do we do that? We take the decimal, 0.6915, and we multiply by 200. this is saying 138. Now remember, we round to the nearest whole because we're talking about people. So 138 out of 200 shoppers are going to spend more than 37 minutes. Now, why do we do this? Okay, instead of just saying 69.15%. One of the reasons is that it can be easier to think about it in terms of a number instead of a percentage, right? We talked about this, I think it was the second class when we were talking about the false positives for breast cancer. And we said, actually, if you get a positive, there's only a 10% chance that you have breast cancer, okay, if you get a positive mammogram. You might have seen it even recently if you watch the press briefings that the Governor Cuomo gives in the mornings. If you watch that press briefing, one of the most recent ones, he was talking about the infection rate. And he was saying every person infects 0.9 people. And even he was saying, okay, well, that doesn't make sense. I don't know what 0.9 of a person is. Well, if we convert it to numbers that make sense, sometimes it can help us understand something. So we wouldn't say every one person infects 0.9 people. The way that we would phrase it so it makes more sense is to say, if you have 10 people, they're going to infect 9 more people, okay? So if you have 10 people who are infected with the coronavirus, they're going to go and they're going to affect 9 more people, as opposed to originally when this whole thing started, every 10 people who you had, they were affecting 14 more people. And that's what was causing this huge increase. Now it's starting to go down because it's less than 1. Each person is infecting only, every 10 people is only affecting 9 people. Okay, so that's the difference. But sometimes that can make it a little bit easier to understand rather than 0.9 of a person, or even what does 69.15% mean. So this can be clear to some people, okay, that if we have 200 people in a store, 138 of them are going to spend more than 37 minutes in that store. Now that might come into play if any of you are still going shopping for food. There's still some lines, okay, out there. There's still a lot of lines. So if you're being told that there are 200 people in the store and 138 of them are going to spend 37 minutes and they only allowed, let's say huge store, they only allow 200 people in the store at a time. Like, let's say Costco, okay? Costco only allows 200 people in a store at a time. Well, you want to know, okay, how long are you going to be on a line? Well, if of those 200 people, 138 of them spend more than 37 minutes in that store, you're going to be online for a very long time, okay? Okay, let's just do one more example, okay? Let's say in a recent world study, on happiness, participants rated their happiness on a scale of 0 to 10. So 0 would be their worst possible life. Whereas 10 would be you have the best possible life. So the mean was 5.4. And the standard deviation was 2.2. So we'll just do 3 different cases. Let's say we want to know the probability that x was less than 4. So once again, so notice every time the steps are the same, we find the z-score. So it's 4 minus the mean, which is 5.4, over standard deviation, which is 2.2. So we go and calculate it, and again, if you want to do it in one step, you would do it as, so I'll clear this. Parentheses, open parentheses, 4 minus 5.4, close parentheses, and then you would divide by the mean. So you could do it in 2 steps or you could do it in 1, that's up to you. And we get negative 0.63. So we're paying close attention to this right in the middle. This is the less than. The probability that x is less than 4 is the same as the probability that z is less than 4. So we just go to our z-scores. Sorry, not z is less than 4. Z is less than negative 0.63. Right? So we're going to go to our z-scores and we're going to go to negative 0.63. So here's negative 0.6, here's negative 0.63. So it's just 0.2643. So probability, we wouldn't turn this into a percent unless we're asked to, okay? Or if we're asked to interpret the results, then typically we would use a percentage. But otherwise, probability is a decimal, okay? Probability is between 0 and 1. Let's do another one. We'll do 2 more. Let's find the probability that x is between 4 and 6. Okay. Well, here's what this is doing. This is saying that the answers, people answered, how many people answered between a 4 and a 6? So we need to find our z-scores. This is the probability that x is less than 6 minus the probability that x is less than 4. Right? We're subtracting. Think back to that normal curve. Think about it visually. This is the area less than 6. This is the area less than 4. When we subtract them, we're getting what's in between. Okay? So we're going to find the z-score for 4, which we already found. And we're also going to find the z-score for 6. So 6 minus 5.4 divided by 2.2. And we get 0.27. So we want the probability that z is less than 0.27 minus the probability that z is less than negative 0.63. So we only need to do the 0.27 because we already have the negative 0.63. So here's 0.2. We're going to go all the way over to 0.27. And we see that that's 0.6024. So it's 0.6024, and then the 0.2643 comes from up here. Now remember, you should always be doing bigger minus larger. If your first one isn't the bigger number, then something went wrong. Okay? So we just put that into our calculator. And that's 0.3381. And if we want to know how many people, out of 800, answered between 4 and 6, we would just take that 0.3381 and multiply by 800, because this 0.3381 is saying about 33.8%. So we're taking 33.8% of 800. And it's telling us that of the 800 people, about 270 answer between 4 and 6. Okay, let's take one last one. Let's do the probability that somebody answer more than 8. Okay, so we need to find the z-score. 8 minus 5.4 over 2.2. Notice when I don't do the parentheses, I do it in two separate calculations. And we get 1.18. So this is telling us the probability that x is greater than 8 is 1 minus the probability that z is less than 1.18. Okay, we have to do the 1 minus, right? Because this is only z is less than. So we go to 1.18. Here's 1.1. We go all the way over to the 0.8, and we get 0.8810. So if we plug in 1 minus 0.8810, we get 0.119. And that's saying approximately 12% of people, right? 11.9% are saying that their life is an 8 or above. Okay, their happiness is rated as an 8 or above. Or more than 8. Okay. So that's it. So this was just a lot of review. It's a lot of the same stuff that we did in the last lecture, but it's really talking about probabilities.